Welcome to our chemistry lesson. Today, we'll explore the fascinating world of atoms, molecules, and chemical reactions. Chemistry is all around us, and understanding it helps us make sense of the world. Throughout this video, we'll guide you through the basic concepts, important principles, and exciting phenomena that make chemistry essential. Whether it's the food we eat, the air we breathe, or the technology we use every day, chemistry plays a pivotal role. By grasping these fundamental concepts, you'll gain a deeper appreciation of how our world works. Ready to dive in? Let's get started with the basics of what chemistry is all about. Chemistry is more than just a school subject, it's the fundamental science of matter in all its forms. Think of it as the study of the materials that make up everything around us and the transformations they undergo. Chemistry branches into fields like organic, inorganic, physical, and analytical. Organic chemistry focuses on carbon-containing compounds, while inorganic dives into minerals and metals. Physical chemistry merges physics and chemistry, and analytical chemistry identifies the components and composition of substances. Every breath we take, meal we eat, and product we use involves some aspect of chemistry, showcasing its essential role in our everyday lives. Next, we'll delve deeper into the basics, starting with atoms, the building blocks of matter. Atoms are the basic building blocks of matter. These incredibly small units compose everything around us, from the air we breathe to the stars in the sky. To understand atoms, let's start with their structure. Each atom consists of a nucleus, which houses protons and neutrons. Protons provide a positive charge, while neutrons carry no charge. Surrounding the nucleus are tiny particles called electrons, which play a crucial role in an atom's properties. These negatively charged particles move around the nucleus in specific regions known as electron shells or orbitals. The number of protons, neutrons, and electrons in an atom determines the element it represents and its characteristics. For instance, hydrogen has 1 proton and 1 electron, while carbon has 6 protons, 6 neutrons, and 6 electrons. Understanding atoms is essential because they form the foundation upon which chemistry is built. As we move forward, you'll see how these building blocks create the diverse world of chemical elements and compounds. In our exploration of chemistry, it's crucial to understand elements as the purest form of substances, made up of just one type of atom. The periodic table is an ingenious tool organizing these elements based on properties, revealing patterns and relationships. Imagine it as a map guiding us through the landscape of chemical behavior and interactions. When Mendeleev first put this table together, it transformed scientists' understanding of matter's building blocks. Each entry on the periodic table holds clues about an element's characteristics, reactions, and role in the vast tapestry of chemistry. As we go deeper, we'll uncover why this organization is pivotal to understanding chemical reactions, bonding, and matter's behavior. Buckle up, because the journey through the periodic table is one of discovery and insight. As we move forward, you'll see how elements come together to form the molecules shaping our world. Molecules form when 2 or more atoms bond together. These bonds can be covalent, ionic, or metallic, allowing atoms to share, transfer, or pool their electrons, respectively. This bonding creates stable structures that make up the substances in our world. One of the most common molecules is water, composed of 2 hydrogen atoms bonded to 1 oxygen atom, forming H2O. Carbon dioxide, another well-known molecule, consists of 1 carbon atom bonded to 2 oxygen atoms, creating CO2. Even the oxygen we breathe, O2, is a simple molecule formed by 2 oxygen atoms sharing electrons. At a fundamental level, molecules define the world we interact with. The diversity in molecular structures results in the vast array of materials and compounds we encounter daily. Understanding how atoms combine to form molecules is crucial, as it lays the groundwork for all chemical reactions and interactions. As we move forward, you'll learn about the different types of chemical bonds that hold these molecules together, revealing the intricate and fascinating ways in which our universe is constructed. Chemical bonds are the essential force that binds atoms together to form molecules. In chemistry, there are three primary types of chemical bonds: covalent, ionic, and metallic. Covalent bonds form when two atoms share electrons, creating a strong and stable connection, often found in organic molecules, like those in living organisms. Ionic bonds occur when one atom transfers electrons to another, resulting in oppositely charged ions that attract each other, typical in salts, such as sodium chloride. Metallic bonds are unique, where electrons move freely in a sea of electrons, holding metal atoms together and giving metals properties like conductivity and malleability. Understanding these bonds is crucial because they determine the chemical and physical properties of the molecules they form. Each bond type has unique strengths and behaviors, contributing to the diversity of chemical compounds. As we move forward, you'll see how these bonds influence the behavior of substances in chemical reactions and beyond. Chemical reactions are processes where reactants transform into products, fundamentally changing the substances involved by altering their molecular structures and properties. How does this transformation occur? During a chemical reaction, reactants engage through their chemical bonds. These bonds break and reform to create new products, often accompanied by energy changes. Reactions can release energy, like in combustion, or absorb energy, as in photosynthesis. Consider rusting. Iron reacts with oxygen from the air to form iron oxide, or rust. In photosynthesis, plants convert carbon dioxide and water into glucose and oxygen, fueling life on Earth. Chemical reactions aren't just theoretical, everyday phenomena illustrate their importance. Cooking, for example, involves heat-triggering reactions that transform raw ingredients into edible food. Combustion reactions power our vehicles by converting fuel into energy. Understanding these processes deepens our grasp of the material world. As we move forward, you'll see how balancing chemical equations ensures these reactions adhere to the law of conservation of mass, maintaining consistency in matter's transformation. Balancing chemical equations is central to understanding the dynamics of chemical reactions. It ensures that the same number of atoms for each element appear on both sides of the equation, maintaining the law of conservation of mass. Why is this important? Imagine trying to bake a cake and ending up with more flour than you started with. The same logic applies to chemical reactions. We need what goes in and what comes out to be balanced. Balancing these equations involves several steps. We start by writing the unbalanced equation, listing all the reactants and products. Next, we count the atoms of each element on both sides. Using coefficients, we adjust the number of molecules to ensure the number of each type of atom matches on both sides. For example, in the reaction of hydrogen and oxygen forming water, H2 plus O2 H2O, you'll find it unbalanced initially. By adjusting coefficients, 2H2 plus O2 2H2O, it balances out. Balancing chemical equations helps us understand the fundamental laws of matter, predict reaction outcomes, and ensure lab observations are accurately represented mathematically. Next, we'll explore the intriguing variety of chemical reactions and understand their types. Stay tuned. Chemical reactions are a fascinating aspect of chemistry, classified into four distinct types: synthesis, decomposition, single replacement, and double replacement reactions. Synthesis reactions involve two or more reactants combining to form a single, more complex product. For instance, when hydrogen and oxygen gases react to form water, it's a synthesis reaction in play. In decomposition reactions, a single compound breaks down into two or more simpler substances. Consider water splitting into hydrogen and oxygen gases. It's the reverse of a synthesis reaction. In single replacement reactions, an element replaces another in a compound. An example is when zinc reacts with hydrochloric acid, displacing hydrogen and forming zinc chloride and hydrogen gas. Double replacement reactions occur between two compounds, where components swap partners to form two new compounds. A classic example is the reaction between sodium chloride and silver nitrate, producing sodium nitrate and silver chloride. Understanding these types helps us decipher how and why substances change during reactions, whether they combine, split apart, or exchange parts. As we move forward, you'll see how these reactions form the backbone of countless processes around us. Acids and bases are fundamental concepts in chemistry that help us understand how substances interact. An acid is a substance that can donate a proton, while a base can accept a proton. But how do we measure their strength? This is where the pH scale comes in. The pH scale ranges from 0 to 14, with 7 being neutral. Acids have a pH of less than 7, and the lower the number, the stronger the acid. On the other hand, bases have a pH greater than 7, and the higher the number, the stronger the base. Consider some common examples. Lemon juice and vinegar are well-known acids, giving off a sour taste. In contrast, baking soda and soap are bases, often giving off a slippery feel. Understanding the properties of acids and bases is crucial because they play an indispensable role in our daily lives and industrial processes. For instance, acids are often found in foods and are critical in digestion, while bases are common in cleaning products and antacids. So, acids and bases, while seemingly simple, are crucial to many aspects of chemistry and life itself. As we move forward, you'll see how these properties lay the groundwork for more complex chemical interactions. Now, let's delve into common misconceptions in chemistry and clear out those cloudy concepts that might be holding you back. Let's clear up common misconceptions in chemistry. First, the idea that atoms are indivisible is outdated. Atoms consist of smaller particles, protons, neutrons, and electrons. Second, chemical reactions don't create matter, they transform it from one form to another. Understanding these clarifications helps us grasp the true nature of chemical processes. As we move forward, you'll see how these foundational concepts interconnect with broader principles in chemistry. Chemistry is far from just a subject in textbooks, it's a crucial part of our daily lives. In medicine, chemistry is at the heart of developing drugs and treatments that save millions of lives. The chemistry behind antibiotics, vaccines, and cancer therapies empowers modern healthcare. Turning to environmental science, chemistry is pivotal in understanding and combating pollution. Through chemical analysis, we monitor air and water quality, develop cleaner technologies, and find sustainable solutions to environmental problems. And let's not forget chemistry in our everyday products. From cleaning agents to food preservatives, chemistry is integral to the products we rely on daily. These real-life applications demonstrate just how vital and versatile chemistry is in our world. As we move forward, you'll see even more fascinating ways chemistry impacts our lives. The future of chemistry is truly promising. Emerging fields like nanotechnology and green chemistry are at the forefront of innovation. Future discoveries could revolutionize our understanding of the universe. Chemistry plays a crucial role in addressing global challenges such as climate change and disease. Through groundbreaking research and collaboration, we can develop solutions shaping a better future for all. As we move forward, you'll see how these advancements might unfold, offering hope and inspiration to the next generation of scientists and learners. Stay tuned for the concluding segment, where we'll recap our journey and highlight the importance of understanding chemistry. Let's recap what we've learned. We started with the fundamental building blocks, the atoms, and saw how they join to form molecules. We also delved into chemical reactions, where these molecules transform in fascinating ways. Understanding these concepts is not just essential for chemistry, but for comprehending the world around us. Chemistry explains the makeup of matter and the changes it undergoes, connecting everything we see and do. Stay curious and keep exploring the wonders of chemistry. Thank you for joining us on this chemistry journey. From tiny atoms to the vast possibilities of future chemistry, we've covered a lot. If you enjoyed this video and found it informative, please subscribe to our channel and follow us for more engaging content. Remember, the world of chemistry is vast and full of surprises. Keep exploring, stay curious, and continue your educational adventure with us. Your journey into the wonders of chemistry has only just begun. There's so much more to discover.